Hello guys, in this video we'll be looking at more, or the more concept. So we're going to start off by saying what is a more. So when we're looking at the more is the amount of particles contained in a substance. Okay, now what you need to know that there is something called Avogadro. Okay. Avogadro is a constant number, okay, which is just 6.022 times 10 to the power 23 particles. So meaning that in every substance there is as many particles as there are 6.022 times 10 to the power 23 particles. Okay, so this is what we call the Avogadro's number. Okay, now the other concept is that in one mole of every substance contains 6.022 times 10 to the power 23 particles. Okay, so if they ask you to say the number of particles, okay, let's say find the number of particles in a sodium element, for example. So what you need to understand is sodium element. So now we are going to say every element, so one more of that sodium, which is Na, contains as many particles as 6.022 times 10 to the power 23 particles. Okay, so that's the most fundamental key to understand about the more concept. And then the other thing is that when we want to understand the more concept is that we have to understand what is called atomic mass number. Okay, mass number and also relative molecular mass. Relative molecular mass. Okay, so when you look at the atomic mass number and relative molecular mass of an element that is, for instance, sodium, okay, which is that, and that of a compound. Compound like carbon dioxide. Okay. So the key fundamental principle is for us to understand what is the atomic mass number, what is the relative molecular mass. So, for example, when I'm talking about the atomic mass number of an element, if I gave you sodium, which is, when you check on the periodic table, it is written like this. Now, whenever we are dealing with the mole concept, the mass number is this number on top. Okay, and this is the mass number. Okay, presented by A. And this is the proton number. Okay, the proton number. So the proton number, okay, presented by Z. Okay. So the mass number, the atomic mass number of an element is just the individual relative mass number of sodium. Okay. However, when you're looking at the relative molecular mass of that element, we are simply referring to something like a compound. In this case, carbon dioxide, water, as well as also maybe ammonia. Okay. So these are compounds on which you normally have to find the relative molecular mass. Relative molecular mass. Now, the relative molecular mass has got a symbol of Mr. Okay, most of the time we use Mr. So relative molecular mass or relative mass. And then when you're looking at a single element, okay, a single element like sodium, okay, we are looking at relative atomic mass number. So in this case, it is just 23. It is just 23 grams. Okay. And now, if we looked at the relative molecular mass of carbon dioxide, this one, water, and ammonia, the way you can go about it is finding the Mr. Okay, finding the Mr. of carbon dioxide, H2O, and ammonia. Okay, so the most fundamental is you have to know the individual masses. Okay, so oxygen, we have 2 of the oxygen there. So all you have to do is when you go to the periodic table, you'll find that C is carbon. Okay, so this is carbon, and this one is oxygen, and this one is also oxygen. So now the carbon on the periodic table is like this. Okay, the oxygen is 16 8. Even this one or 16 8. So the numbers that you're interested in is these that are on top. Okay, 16 there, 16 there. Okay, and the way you can look at this one is now carbon is just 12 and oxygen is just 16. And remember, we have got 2 oxygen there, so we have another oxygen that is 16. So now all you have to do is the CO2 is just going to be 12 for carbon plus 16 for oxygen plus 16 for another oxygen. And this all together will just give us, I think we have something like 16 plus 16, that is 32, plus the 12, that is 44. Okay, grams. So this will give us 44 grams. Okay, so now the way we have found the mass, the relative molecular mass, is only you have to do the individual masses. So you have to know the mass of the individual element in that compound. So for example, carbon, oxygen, oxygen. And then now we add them together like that. Okay, so that's how you find the relative molecular mass of a substance. So thank you so much, guys. We'll see you in the next video. Please make sure that you do subscribe to my channel for more information. And work, if you love our work, please share and like this video. Thank you so much. And this is Radical Academy. Okay, welcome to the second video of the topic, the mole concept. So in this one, we'll look at finding the physical mass of any substance using the molar mass, which is Mr., and the physical volume of any gas at this condition, RTP, and vice versa. So in this example, we'll look at how to find the mass given the number of moles. How to find the mass given the number of moles. Now there is something that we must be able to understand, okay? So the first procedure that we must understand is we must look at what is the formula. So the formula is that number of moles, okay? Number of moles is equal to the mass of that substance divided by the molar mass or relative mass, molar mass. Okay, meaning we can say that N, number of moles, equals to the mass given over the Mr. Okay, relative molecular mass. Or you can also say that the number of moles is equal to the mass, okay? The number of moles equals to the mass over the relative atomic mass. So you have to be careful, because when you're dealing with the first formula on top, where this one is the Mr., then you are dealing with the substance given is a compound or a molecule, okay? So a molecule. When you're dealing with this one, then you are dealing with an element. An element, okay? That is, for example, let's say just a single element like sodium, or even just magnesium, okay? So make sure you take note of the differences between the formulas, despite the formula being the same. Okay. So now from there, Let us look at the examples. Calculate the mass of 0.5 moles of bromine atoms. Okay. So the first thing that you're supposed to do on number 1 is, first of all, you have to ensure that you collect the information. So we are looking for the mass, so you put a question mark, and then we're also looking at the moles. Okay, we have been given the moles 0.5. So the moles is 0.5, and finally, since you are looking at atoms, okay, single element, so it is this one. So it's bromine, so it's just 8 grams. Okay. Now this number can be found on the periodic table. Okay, you just look up the periodic table, then be able to find this number. So now, therefore, the number of moles equals to the mass over the AR. So look at the formula, because I'm looking at a single element, bromine. Okay, so in this case, N will be equal to, the N is 0.5. Okay, so 0.5 we replace now is equal to the mass over 80. So since now this is a fraction, you can just put over 1, then you cross multiply. 1 times m is going to be m. So 0.5 times 80. Okay. So once you do multiply that one, you're going to get the mass as just 40 grams. 40 grams of bromine. Just get 40 grams of bromine. Okay. On number two, when you go back to the question, first of all, collect the information. So we know that we have been given the moles 0.5, and we are looking at the molecules. So molecules is just a kind of a substance that contains 2 or more atoms. Okay. So an element that contains 2 or more atoms is what is known as a molecule. So again, in that case, okay, so we are going to say now that the mass is what we are looking for. The mass is just a question mark. And then we are looking at the molecule. So the molecule is Mr. Since there is more than one. So this is going to be meaning 80 multiplied by 2. Okay. So where is this 80 coming from? So when bromine is a molecule, it is written like this. So we have 2 bromines. So it's like bromine 80, and then another bromine 80. So therefore, you shall have 80 plus 8. Okay. So that is what is happening. So this is where we are getting this. So this will be just the 160 grams. And the Mr., that is the Mr. Now the number of moles has been given as 0.5. Okay. So from there now, we are going to look at the formula. So what's the formula? Is N equals to M over the Mr. Okay. So we know the value of N, 0.5 is equal to the mass is what we are looking for. So we just say it remains unchanged. over the mixture is 160 grams. So just put over 1 and then you cross multiply. So this is going to be 1 times m. So it's like 1 times m, then equals to 0.5 multiplied by 160 grams. Okay, and this will just give us 80. Okay, 80 grams. Okay, so that will just give us 80 grams. So the last question now is, so the last question, also solve it, collect the information, the data. Okay, so this one, going back to the information that you're given, when you look at that one, they're saying how many moles, so how many moles of oxygen molecules. So when they are saying molecules, they are talking about more than one atom of oxygen. So how many molecules are in 64 grams of oxygen? Okay, so in this case, we have been told that the mass is 64 and we are looking for the number of moles. So the number of moles is we don't have, and the mass is 64 grams. And the mixture, since it is a molecule, is the mixture of oxygen. What you need to understand, since it is a molecule like this one, so the molar mass or relative molecular mass of this molecule is just 16 times 2, or just 16 plus 16, since you have 2 oxygen, and this will give us 32 grams. Okay, so from there now, we're going to say number of moles is equal to the mass over the mixture. Okay, and we know that this can just be like this. So the number of moles is what you're looking for. The mass is this one, 64. So 64 divided by 32. So the mixture is 32. So 32 milligrams per mole. This is also the mass. So the G cancels. So from there now, you know that the N is just going to be 32 into 64. You're just going to get 2 moles of oxygen. 2 moles of oxygen. Okay. So thank you so much. Now let us look at how you can deal with gases. Okay, how you can deal with gases. So that will be our part 3 of the gases. I don't want to confuse you, but what I want you is to understand this and make sure that you practice a lot. Okay, so thank you so much. But let us go to the volume of the gas. Okay, so I want you to stop right there. Okay, I want you to stop right there. Okay, so when you look at the question that I have here, saying how many molecules are there in this, in 18 grams of hydrogen, this one, 4 grams of water. So this is an exercise for you. Now, if you find the answer, okay, so pause the question, pause the video, and try to go through this exercise and see if you have understood. Hope you find the answer correctly. Now check the answers if Now, whenever you come across these molecules, okay, you are looking at atoms more than one atom, so two atoms and above. So there, what we do now is, okay, we have to collect always the information, okay? So for the number of moles, if you put question mark, what have you been given? The mass 18 grams. So the mass is just the 18 grams. And from there, what do we want? We need to find the mixture. Okay. Now, this is looking at hydrogen. Okay. We are looking at hydrogen, which is just like this. Now, when we go on the periodic table, hydrogen has a mass of 1. So in this case, all you have to do is either you say 2 divided by 1, or just this one. Hydrogen can be 1 plus 1. Okay. So it just gives us 2 grams per mole. Okay. So that's the key concept there. So therefore, our meter is simply 2 grams per mole. So from there now we can say, therefore, the number of moles is given by n over the mixture. Okay. Now we are looking for n, so that we go direct. The mass is 18 grams over, okay, over meter 2 grams per mole. Okay. The gram goes, and we are going to have 9 moles. 9 moles of hydrogen. Okay. 9 moles of hydrogen. So that is your answer on A. I hope you got it correct. And now for B, you're going to some here. Now for B, the information that you have is as follows. So number of moles is what you're looking for, and the mass is given as 54 grams, and we're looking at the mixture. Okay, and we're looking at the mixture of water, which is H2O. So water is compound, so we have to find the relative molecular mass. So 2 hydrogen there, the same as doing 2 times 1. And also oxygen, just 1 oxygen, and the mass number 16. So this will give us 2, this will give us 16. Therefore, now we can just add them, okay, meaning 2 plus 16 is 18 grams per mole. So from there now, therefore, formula is number of moles to the mass over the mixture. Okay. So for number of moles, so we maintain this one, n equals to the mass is 64. So 4 grams divided by 18 grams per mole. Okay. So n is equal to 3 grams. Once you calculate that, it just give you 3 moles of water, which is H2O. Okay. So that is simple that exercise. I often believe that you have actually answered the question accordingly. Thank you so much for watching, and this is Radical Academy. Hello guys, welcome to the video, and this is gases. So in this video, we look into that part of what is mole and look at how you can define number of moles and the mass, also mass and the number of moles. Now, in this video, we're going to look at that you can understand about gases. So one of the most important things to understand about gases is that one mole, okay, one mole of any gas is actually going to have a volume of 24 centimeter cubic. So that is this condition RTP. Okay, so RTP simply means room temperature, and pressure. So room temperature and pressure means you have a gas occupying a space of about 24 centimeter cubic. Now, another important thing to understand is also STP. Okay, so we have two conditions: we have STP and RTP. So for this point, STP stands for standard temperature, okay, and pressure. Temperature and pressure. Okay. Now this one, on this one, the volume is 24 cubic centimeter, and on this one we have the okay. So on this one we normally have the volume as before. I mean, could be 22. So we have the temperature. I mean, the volume is 2,400 cubic centimeters. Okay, that is the volume at 80. So 2,400 cubic centimeters. Okay. So now the volume is somewhere around 2,400 cubic centimeters. So kind of this one, probably I think not mistaken. Okay, so when you compare to decimeter, you have 2.4 decimeter cubic. Okay, so these are the most standard thing that you understand about gases. Now we know that how you are converting, okay, converting from meter to centimeter cubic. What you know is one one decimeter cubic same as 1 liter, which is equal to 1,000 cubic centimeters. Okay. So always ensure that when you're putting volume in cubic centimeters, make sure you take it back to the centimeter cubic. And for example, if example say convert 100 cubic centimeters to decimeter cubic. So convert this, okay, convert 100 to this standard. So standard unit is a liter or decimeter cubic. So what you know is 1 decimeter cubic is equal to 1,000 cubic centimeters. Now, what x the cubic is going to be 100, this one. So you cross multiply. So the 1,000 times x, so 1,000 x is equal to 1 times 100. So that's 100 there. So you divide both sides by 1,000. This and this goes. So x, 0, 0, 0. So that's 0.1 decimeter cubic. So that is how you compare. So make sure that you always understand that part. Okay. Now, what are we looking at then? So when we are talking about the gases, formula is the same, that the number of moles is equal to the mass, okay, of that, I mean, instead of the mass, I'm going to say number of moles equals to the volume over the molar volume, mv. Okay, so this is the formula. Okay. So the only thing that is that the volume given and the molar volume. So the molar volume is 24. Okay, molar volume, which is mv. Okay. So you must understand 1 mole of any gas is going to occupy this amount of volume at RTP, and at ATP is going to occupy this 0.4 decimeter cubic. Okay. So now let's look at an example so that you understand what we are talking about. Okay. So let's look at an example. So we are saying what volume does volume does 0.25 moles of a gas prepared at our TP. So you have the gas, volume, okay, volume that 0.25 moles of a gas occupied. Now, as long as you're giving the gas, then you have to go back to this point. So 1 more of this is going to occupy a volume with the cubic and RTP. So what information do you need? So get the information there we're going to have number of moles is n equal to 0.25, and the molar volume, which is mv, is equal to 24 meter cubic for RTP. And then the volume equals the question mark. And what formula do you use? You use this formula. Okay. You use that formula. Okay. So now, what we're going to use is a number of moles equal to the mass, the volume. The volume divided by molar volume. So we are looking at the volume. Okay. So we are looking for the volume. So from that point now, going to go forward, then we cross make. So we are make the sub, okay, of subject formula. Okay. So 1 times V is equal to V, then N times MV. Okay. And the volume is number of moles 0.25 more divided by molar volume is 54 centimeter per mole. From there, this more cancels. Our volume will now be 0.25 divided by 4. Then from there now, you have now amount 6 decimeter. Decimeter, or when you compare to that, we're going to have 6,000. Okay. So 6,000 at our TP. Okay. So the volume.